Now let's talk about the direction of the displacement and the absolute velocity. The good news is, since we're dealing with one-dimensional motion, both of them are one-dimensional vectors. And if you recall, we mentioned previously that we can simply deal with the directions of one-dimensional vectors by playing with the positive and negative signs of their values, right? So let's do that. So we have a particle that's moving around along this x-axis. And to the right will still be our positive direction. And when it comes to units of the position and displacement, we're going to go with the SI unit, which is meter. So let's say the particle starts from the initial position, which is -3 meters. Well, that simply means that the particle starts somewhere on the left-hand side of the origin. After a while, it moves to the final position, x of f, which is, let's say, +5 meters. Now, to compute its displacement, we do x of f minus x of I. Now, the order is very important. So remember that the delta symbol, which is the little triangle in front of x, is always asking us to take the final value of this quantity minus the initial value of this quantity. So always final minus initial. So the final value of the position is +5, right? Minus the initial value of the position, which is -3. So you do want to respect the negative sign that was originally there in the initial position. Okay, so once you do the algebra correctly, so 5 minus -8, 5 minus -3, which gives us +8 meters. I know that we didn't have to leave that explicit positive sign there. So in math, we'll just omit it. But here, I do want to emphasize that we do have a positive displacement, which represents a displacement that's in the same direction as the positive x-axis. In this case, it's actually going to the right. Does it make sense, though? Well, it kind of does, right? You know, you have an object that starts from the left-hand side of origin and ends up being at the right-hand side of origin. So that means that it must have been displaced to the right. Now let's try a different set of initial and final position. So let's say xi will be maybe, let's just swap the starting and end point of the process. All right, so x of I, let's take it to be 5 meters, which was the final position, right, for the previous scenario. But we're going to take that as the initial position here. Now the final position this time will be -3 meters. So now let's say the displacement will still be x of f minus x of I. Okay. So now the x of f will be -3, right? xi will be 5, right? So now we get -8 meters. So now what's the difference between these two displacements? Yes, exactly. So they have the same exact magnitude, but their directions are opposite. So in the second case, the displacement is negative, which means that the direction of such a displacement must be in a negative x direction. So in this case, is to the left. It does make sense, right? Because, you know, we are starting from somewhere on the right-hand side of the origin, ends up being on the left-hand side of the origin. Now, what about the direction of the absolute velocity? Well, it's fairly simple. It turns out that the average velocity is going to have the same exact direction of the displacement. And you can see that from the mathematical definition of the average velocity. Right? If you remember that the average velocity is nothing but delta x divided by delta t, right? And remember that delta t is nothing but the final moment minus the initial moment, which has to be positive at all time since the time never goes back. So now, don't you think that the polarity of the numerator of this fraction here, which is the displacement, will tell us the polarity of the average velocity, which means that if the displacement is positive, which means the motion is moving to the right, and the average velocity will have to be also positive, right? And if the displacement is negative, the average velocity is going to be negative. It's all because of the positive denominator. So simply put, the average velocity and the displacement is going to have the same exact polarity in their values. Therefore, they will have the same direction, right, for the corresponding motion, thanks to the fact how we define the average velocity based off the displacement.